All right, class, so now we get to the fun stuff, all right? We've taken equations and created real-world situations from them, equations and inequalities, and we've also looked at real-world situations and was able to make up either an equation or an inequality for it, okay? So now, we're actually gonna solve this stuff, okay? We're gonna bring everything together now in the next week. So let's start with the concept of zero pairs. What a zero pair basically is a number and its opposite. The sum is going to always equal to 0. Okay? So if we take -2 and we add +2, it's going to be 0. Okay? If we take +3 and we add -3, it's going to be equal to 0. So that is just a concept of zero pair. The other thing you need to learn is an inverse operation. Okay? So the inverse of addition is subtraction. The inverse of division is multiplication, okay? So just keep those things in mind. Here are the key things we need to do in order to solve equations. Number 1, we need to combine like terms if needed. Number 2, always start by getting rid of the constant by adding or subtracting it, okay? So we're always gonna do an add or subtract before we do a multiply and divide. That is a very key thing. Next, take care of all multiplication and division last. Our goal, our objective is to get x all by itself, okay? So first I'm going to start with a model. Let's say we have 2x plus 3, and we're going to make that equal to 7, okay? So this is how it would look like in a model. We have 1x, 2 x's, all right? Plus 3, that's going to be positive, 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 okay? Now we have 7 over here, so that's going to be +1, +2, 3, 4, 5, 6, and 7, okay? So, these sides are equal to each other. What I want to do is try to get some zero pairs to cancel each other out so I can get the x's all by themselves, okay? So, I know that this cancels with this. I know that this cancels with this. Also, this cancels with this. So, I have 2 x's left, but I have 4 quantities. So what I basically have right now is 2x is equal to 4. 2x is equal to 4, okay? I just subtracted 3 from each side. Now, I'm going to go ahead and draw this one more time. We have 2 x's, and then that's going to equal to 4. Okay? So now, all I'm going to do is divide each side by 2. So this is going to be one group, this is going to be another group, this is one group, and this is another group. So I know for sure that 1x is going to be equal to 2. All right? X is equal to 2. It makes sense. 2, if I plug in 2 for x, I'm going to get 2 times 2, which is going to be equal to 4. And 4 is, of course, equal to 4. Okay? So this is how you would solve this with a model. Now, we're going to just go ahead and solve it numerically. Here are the steps that I would like to see when you're solving these problems. So I'm going to go ahead and take away 3 here and take away 3 here. 2x is going to be equal to 4. So as you can see, it's the same as the model I drew with the algebra tiles. This is just the algorithm way of doing it, okay? I know 2x is showing multiplication, so I perform the inverse operation, which is to divide. So I'm going to divide by 2 and divide by 2, so x is going to be equal to 2 in this situation. And this is how this works. So we're going to go ahead and try about 6 more examples so you can see all the different scenarios moving forward. Let's try 3x minus 2. 3x minus 2 is going to be equal to 13. Okay? So I have subtract 2. So I have to perform the inverse operation in order to get my zero pair. So I'm going to go ahead and add 2 here and add 2 here. I have 3x is equal to 15. Okay? The operation I have right here is multiplication. So I'm going to inverse that. The inverse of multiplication is the divide. So I'm going to divide by 3 and divide by 3. X is going to be equal to 5 in this situation. Okay? Let's go ahead and try another. We have 20 plus 8x is going to be equal to 36. Now if you look here, our constant is first and our variable is second, okay? Our goal is still to get rid of our constant first. So I'm going to go ahead and subtract 20 and subtract 20, okay? Even though there's an addition sign here, that doesn't really matter. My job is to get rid of this constant, okay? And that is by doing a zero pair in order to get this away. So now I have 8x is going to be equal to 36 minus 20, which is going to be equal to 16, okay? Now, remember, goal is to get x by itself. This is multiplication. I'm going to perform the inverse operation, which is to divide by 8 and divide by 8. X equals 2, okay? Now, I could go ahead and plug that in and see if that makes sense. 3 times, oh, I'm sorry, that's the wrong one. 8 times 2 is 16. 20 plus 16 is going to be equal to 36. So by plugging in, I can check to verify if my answer is correct. Try a couple more. We have 100 minus 20x, 20x is going to be equal to 40. 20x. There we go. One more time. Constant is first. Even though that there's a subtraction sign here, it doesn't mean I have to add 100. I'm going to subtract 100 because my goal is to get rid of that 100. Okay? So I have negative 20x is going to be equal to, we have 40 minus 100. 40 minus 100 is going to give me a negative 60. It's going to give me a negative 60. Okay? This is why we worked with integers. We need to figure out how these negative rules work. So I'm going to divide by negative 20 and divide by negative 20. X is going to be equal to 60 divided by 20 is 3. Negative divided by a negative is a positive. So x is equal to 3. Let's see if that makes sense. 100 minus 20 times 3. 20 times 3 is 60. So 100 minus 60 is equal to 40. Absolutely, that's correct. Now, these are the ones that students struggle with most, but I don't want you to be intimidated by these. Just follow the same rules, okay? I'm going to add 2 and add 2 because you want to get rid of your constants first. So half of x is going to be equal to 10. Half of x is equal to 10. So now I need to perform the inverse operation here, right? So in order to divide a fraction, I have to multiply it by its reciprocal. So I'm going to multiply by 2 over 1. All right, so reciprocal is just flipping it over. Multiply by 2 over 1, and then I'll put a 1 over here to make this a fraction. Now, 2 over 1 times 1/2 is just 2 over 2. So that means I have 1 here. So this is 1x. I'm just going to put x by itself. I don't have to do it. I don't have to write the 1 here because I have 1x. 1x is 1x. 10 times 2 is 20 over 1. So x is equal to 20. Let's cycle back and see if that makes sense. Half of 20 is 10. 10 minus 2 is 8. So that definitely works. Let's just try a couple more so that you'll see as many examples as possible. 3/4 of x plus 4 is going to be equal to 13. Once again, get rid of your constant first. So we have minus 4, all right? So this is going to be equal to 3/4 x is equal to, let me cancel that out, 13, 12, 11, 10, 9. 9, okay? Now, I need to get rid of this, so I need to divide. In order to divide, I multiply by its reciprocal. So multiply by 4 over 3, multiply by 4 over 3. Let's put a 1 here so we can multiply that fraction. This is just going to be equal to 12 over 12. 12 over 12 is just 1. So x is equal to 36 over 3. X is going to be equal to 12. See if that makes sense. What's 3/4 of 12? 3/4 of 12 is 9. What's 9 plus 4? 9 plus 4 is in fact 13. Now, for some of the advanced students, I'm going to have situations in which you have to compare like terms, combine like terms. So I have negative 4 plus 2x minus 3 is going to be equal to 7. Okay? So these two, I could combine them, can't I? This is a negative 4 minus 3. So it's negative 4 plus negative 3, which is equal to negative 7. So negative 7 plus 2x is going to be equal to 7. So remember, in some situations, you're going to have to combine the like terms first. Now, I'm going to add 7 and add 7. Remember, I want the inverse operation. So 2x is going to be equal to 14. 2x is equal to 14. I'm going to divide by 2 and divide by 2. So x is equal to 7. Let's see if that makes sense. Negative 7 plus 2 times 7. So negative 7 plus 14. Signs are different, so I have to subtract. So 14 minus 7 is in fact 7. And this works. Okay? So remember your rules. You're trying to get the 0 pairs first, and then you'll multiply and divide at the very end. I've shown you all of the scenarios we'll have with fractions and integers, but of course sometimes we'll be working with decimals as well, but same rules apply. Okay?